Here's a UQ past exam question. Where does the function x minus 2y plus 2z have maximum value on the sphere x squared plus y squared plus z squared equals 1? Well, we're going to use Lagrange multipliers for this. So that is grad f equals lambda grad g, where g is our constraint. So f is this, and g will set as x squared plus y squared plus z squared minus 1. Okay, so taking the gradient vector for each of these, grad f is the vector fx, fy, fz. And so we have 1 minus 2, 2. Grad g is the vector gx, gy, gz, which is 2x, 2y, 2z. Okay, so using the two of these in here, we have this vector equation that gives rise to three scalar equations. And so that is 2x lambda equals 1, 2y lambda is minus 2, 2z lambda is 2. And we want to solve this as a simultaneous system. Now, one way to do that is to eliminate lambda in the equations, and we can do this by dividing one equation by another. So taking this second equation, dividing by the first, we have y over x equals minus 2. Doing the same thing with the second two equations, we have this, and so we can write the two of these as y equals minus 2x and z equals minus y. Now, don't forget about the constraint, which says x squared plus y squared plus z squared equals 1. So let's sub these into the constraint like so. And now you can see that we can solve this for x. So that's what we want to do next. So this gives us 9x squared is 1. And so x is equal to plus or minus the square root of 1/9, so plus or minus 1/3. Okay, so taking these two values and putting them in here, we have this for y and this for z. And so this gives us 2 points like so. And so you can see that these are clearly on the unit sphere. So now what remains is to just work out which one gives a max and which one gives a min. Because we have 2 here, we can just compare the values. So we sub these into f, and we get 1/3 of 1 plus 4 plus 4, which is 9 over 3. That's 3 for this point. Similarly, for the other point, we have minus 3. Okay, now which one of these is greater? It's clearly this one. So this gives a max, and this gives a min. And there we have it.